Hey everybody, welcome back. Back for Machine Tool Monday. We're going to get back on the mill, do a little work on the mill today. We got our power feed on there last week, and this week I got a contactor switch for forward and reverse. I have been missing this ever since I got this mill. When we were in our old shop, we didn't have three-phase electric. We had single-phase, so I had a variable frequency drive on the mill, and that allowed me to, go forward and reverse. Since we moved here, we have three-phase, and I've just been using a regular on-off switch, and when I have to reverse the mill, I have to unhook the wires, and it's just a real hassle. So anyway, since we started kind of trying to get everything buttoned up, cleaned up, and working better on this mill, got our power feed, I went ahead and ordered one of these, and we're going to get this put on today. Also, my on-off switch is like down low and behind the machine, so I'm constantly having to lean over the table, which is definitely probably not the safest thing to do. So we are going to get out there and try and get this hooked up today, and possibly look at making a cover for that brass gear on the power feed, being that since we modified a Bridgeport type power feed, the cover wasn't available and didn't work right. So I don't know if I have any material to do that or not, but we'll see what we can come up with as far as that goes and see what time allows. So like I said, first things first, we're going to hop out there and get this done. All right, so we got our wiring here. We'll go ahead and separate these out. We got the three that go into the motor and the three that come in feed power. So we got our ground in here. All right. So first things first, we got to figure out how to mount this switch box. We got this old box, which is kind of in the way, but I don't really want to take it off, I don't think, because of the way the wires go. So I'm gonna see, let's see here, if we feed these through. That's what we need to do there, is just put a couple holes in here, a couple holes in here. That'll let us mount this. So you can grab a drill bit and a drill, a couple 1/4-inch bolts, and we'll come back and get this thing drilled out. Alright, so I'm going to go ahead and snip these wires off and strip a new clean bit of wire, and then install them underneath each one of these screw terminals. ring connector on the ground, so it's easier to mount on this bolt. Then just slid it over and put another nut. So that's it. You just make sure the wires are tucked down, tucked up. Slide this cover on. So there we have counterclockwise. There we have clockwise. Man, that's going to be nice having a nice, easily reachable switch. So I think the next thing we're going to do, the next upgrade this mill needs is a DRO. It's a digital readout. So what we need to do is measure our travels on all three axes so we can figure out what type of scales we're going to need lengthwise to retrofit this with a DRO. Alright, so we're going to measure our table travel here. We've got it all the way one way. We're going to make a mark on the table and the knee, and then we're going to move it all the way over to the left, and that'll give us our actual length of travel. When we measure between those two marks. Alright, so our actual travel is about 28 inches. So next we're going to move the Y all the way out. Do the same thing, we'll make a mark underneath here. Go ahead and measure our marks. Looks like we got about 10 inches in. So we got. So last one, same thing, make a mark. Alright. I don't think I'll be bringing it up much higher than that ever. There we got 13 inches. Alright, last thing to do today is see if we got something to make a cover for this. So, looks like we need a piece of material about 3 inches long. By about 3 inches around. So, I'm going to go dig through my stock and see what I got. Alright, so I don't have any material that size, but I had a thought. I think I'm going to go inside and see if I can draw one up real quick and 3D print it, because a plastic cover would work just fine. So we'll hop inside on the computer and see what we can come up with. Alright, so we're going to draw this up in Tinkercad. I am a terrible 3D modeler. I do a lot of 2D stuff for the plasma table. I've just never learned 3D, which I need to do, but it's just not something I'm very good at. But I can usually get through simple things like this. So this thing only seems to have metric dimensions in it for some reason. So I have to convert all my measurements here. So our outside diameter is 3.150 times 25.4 is 78.75. 78.75. 78.75. So that's our outside dimension. Our height is going to be 2.087. 2.087 times 25.4 is 53.0098. So we'll call that 53.1, 3.1. Okay, now we need to put two holes in this. So the first hole, all right, so we got our first dimension drawn. We're going to add another cylinder here, which is going to be our first hole, which we need to be where's our dimension? Is 0.7930 times 25.4. We need it to be 20.14 millimeters in diameter. So we're going to do 20.14. And we'll do 20.14. And now we're going to align these two, so we'll go ahead and select them. We're going to align them. So we want to align the centers. We want to align this center. And then we want to align this center. And now what we need to do is click on this. If I hadn't, I might have jumped the gun here. Let's see if we can get it still. Where's our height dimension? All right, I might have jumped the gun on that. So let's do this. We're going to make this height, let's see, unselect those. We got to make this height. We'll make it 60. Now we want to group them and align them. So we're going to align center here. We want to align center there. Then align center there. So now we're going to click over here. Now they're aligned. We're going to make this a hole. Now we're going to select this. Select them both. We're going to combine. And there you go. We got our hole down the center. So the next thing we need to do is get most of this center hollowed out. I'm not 100% sure if my plan for doing this is going to work. So I want this inside hole. We're going to bring, let's do another cylinder over here. We want to have some wall thickness, you know, for our cover. So we'll go ahead and make this, it was 78 millimeters. So let's see, 78 millimeters. If we want to have like a 1/8 wall, that's like 3 millimeters. So we want a 6 millimeter wall thickness, you know, 3 and 3. So let's just make this 70 millimeters, this one. So we'll go 70. close this up for a second. We'll go 70 there. We'll go 70 here. And then we want to set our thickness on this. So this is 53 millimeters. And our dimension, our minimum clearance, .53.01. That's our height we need for clearance to cover the brass gear. This is the height we need for the clearance to cover the brass gear and the shoulder to fit on the shaft to hold this cover on. Okay, so we want to turn this into a hole also. What we want to do now is we're going to go ahead and align these, and I'm also going to try and align them this way. Okay, yeah, so see, that brought us up high. That's what we wanted. Now we're going to align center. We're going to align center this way. And now we're going to group. Whew, that actually worked. Like I said, I am not much of a 3D CAD drawer, but I can usually fumble my way through these simple designs, you know, geometric circles, squares, stuff like that. So anyway, I'm definitely not teaching you guys anything, but hopefully you maybe enjoy watching the process a little bit. This Tinkercad is an online deal, and it's free to use, so that's why I use it, because I'm not good enough to invest the money in a real program. So now what we want to do is export it. So we want to make an STL because we're going to 3D print it. Comes here in our downloads. We're going to go ahead and open this up in Cura, which is our 3D printer slicer. And in a minute it'll probably be in one of these, I think. We can kind of look here to check our dimensions. So we're 78 millimeters by 78 millimeters by 70 millimeters tall, which is exactly what we want. And we come over here to our settings. This is going to be a piece we're going to have forever, so we'll go ahead and make it a nice quality print, good layers. We'll make it a 50% infill. We want it to be pretty strong, you know, as strong as plastic can be. And we will go ahead and slice this. So we got an 18-hour print, 18 hours and 26 minutes. I got to hop over to the 3D printer, grab our flash card. We'll get that set up. We'll load that, and I'll show you guys how we get operating on the 3D printer. Alright, so this is our 3D printing setup. We got 4 3D printers. We use them for a wide variety of stuff, you know, prototyping parts, making little pieces like this, dash knobs, you know, whatever we can come up with. I thought I had some gray filament, which I wanted to use because the mill is kind of gray, but it looks like I'm completely out of that. So I'm gonna have to just use whatever I got here. I don't even know what are they calling this, brown. I guess we'll use this brown filament. Doesn't really matter. But this is some little end mill holders. We're working on getting our machine cabinet all filled up. So what we got to do here is preheat our machine so we can change the filament. Otherwise, if you try and pull the filament out before it's warm, it'll just break off in your tube, and then you're screwed trying to get that corrected. So, all right, so we got our machine preheated, got the old filament out. We're gonna go ahead and get this kind of tannish brown loaded in here, just because it's what I have, and it really doesn't matter what color it is. I can always paint it black if I decide I don't like the way it looks on the machine, but I'm not really one to care too much about stuff like that. I'm more of a function guy when it comes to stuff like this. So you just feed this through until you get a little bit of filament extruding from the nozzle. So there we go. Jump back over to the computer, save our file on here, and we'll come back and get this thing running. One other thing I do, I spray a little hairspray on my build plate here. Just helps with adhesion. It's just something I started doing way back, and I always continue to do it. So select our file, select print, and we're off to the races. Alright, so just to give you a reference, we've got a 1mm layer thickness in an hour. We have 1% complete in an hour of print time. So this 3D printing is an extremely slow process, but it's a great way to do things. It's very inexpensive. This piece will end up costing about 40 cents when it's done, so it's hard to beat in a lot of ways. Alright everybody, that's going to do it for Machine Monday. Really happy with getting that switch on our mill. Should have done that years ago. And we got all our dimensions, so we're going to look at ordering a digital readout. And when we come in tomorrow, our cover should be finished printing, and we'll see how that fits. I'll show you guys that next time. Hope you guys are enjoying these machine tool videos. Something a little different than the normal motorcycle stuff. Also, if you're a manual mill guy, let me know in the comments what's your go-to manual mill accessory. I'm looking to start adding some serious tooling to my collection. I don't have a ton of tooling. I have, a vise, a rotary table, a couple other small things. So what's your go-to piece of equipment for your mill that you use all the time you couldn't live without? Let me know so I can start figuring out some good stuff to add to my collection. Thanks a lot, and we hope to see you guys next time at Gatti's Garage.